Hey friends, welcome back to Math Defined. Let me ask you something. If a survey says 70% of students want longer lunch, should we believe it? Or could that data be completely misleading? Today you're going to learn how to tell when data is trustworthy and when it's not. We're talking about samples and populations, but even more importantly, we're going to learn how to tell whether a conclusion is actually reasonable. And here's the thing. Today's lesson is not really about heavy computation. It's about thinking carefully. It's about asking questions like, who was surveyed? Who was left out? And can we really trust the results? That's a big deal, not just in math, but in real life too. So throughout this lesson, I want you to think like a detective. I'm going to show you different situations, and I want you to decide, can we trust the data or not? By the end of this lesson, you'll understand how random samples help us make conclusions about a population. Not just what a sample is, but why it matters. Let's start with two important words. A population is the entire group you want information about. That could be all the students in a middle school, all the people in a city, or even all the pet owners in a state. A sample is just a part of that population. It's the smaller group we actually study. And most of the time, we use a sample because studying the entire population is just not realistic. It would take too much time, too much effort, and maybe even too much money. So instead, we study a smaller group and use what we learn to make a conclusion about the whole population. Let's look at an example. Suppose your school wants to know how students feel about having a longer lunch period. The population is all the students at the school. The sample is the group of students we actually ask. Now here's the big question. Does the sample fairly represent the population? Because if it doesn't, then the results may not be reliable. That brings us to an important idea: biased samples. A biased sample is a sample that does not represent the population fairly. That happens when some people have a better chance of being selected more than the others. So the results start leaning in one direction. And that's a problem. Let's go back to our lunch example. Suppose we only ask basketball players whether they want a longer lunch period. Would that be fair? No, because basketball players are only one small group in the school. That sample leaves out lots of other students, so it does not represent the whole school fairly. That would be a biased sample. Now let's take that idea one step further. Even if your math is correct, your conclusion can still be wrong. And that's a really important idea, because in statistics, it's not just about doing the math correctly. It's also about looking at where the numbers came from. So if the sample is biased, then the conclusion may not be valid. It might sound convincing. It might even look official. But if the sample wasn't fair, then the results do not reflect the whole population. That means the data could lead people to believe something that isn't actually true. So whenever you see data, don't just ask, what do the numbers say? Also ask, where did those numbers come from? So if a biased sample is a problem, what kind of sample should we use? A better choice is a random sample. A random sample is a sample where every member of the population has an equal chance of being selected. That matters because random samples are more likely to represent the population fairly. They help reduce bias. Now, random does not mean sloppy. It does not mean just picking whoever is nearby. It means the selection is made fairly without favoring one group over another. So if a school wants to know how students feel about lunch, a better plan would be to randomly choose students from the entire school. Not just athletes, not just one grade level, and not just students from one classroom. That would give the school more trustworthy data. Let's test your thinking. Suppose a principal wants to know whether students think school should start later. Here are 2 ways to collect the data. Option 1, ask only students in first period who arrive late. Or option 2, randomly select students from all grade levels. Which one is better? The better choice is option 2. Why? Because asking only students who arrive late is a biased sample. Those students may already have strong opinions about school starting time, but a random sample from all grade levels gives a fairer picture of what this whole school thinks. Now let's make sure the vocabulary is clear. A population is the entire group you want information about. A sample is the smaller group you actually study. Let's try one. A pet store owner wants to know which type of pet food customers buy most often. They survey 40 customers who shop there on Saturday. What is the population? The population is all customers of the pet store. What is the sample? The sample is the 40 customers who were surveyed on Saturday. But now let's think a little deeper. Is that sample likely to be fair? Maybe not, because it only includes Saturday shoppers. And Saturday shoppers may not represent all customers. So even if we can identify the sample correctly, we still have to ask whether it fairly represents the population. That's what makes data more trustworthy. Let's try one more. A city wants to know whether people support building a new park. They survey 150 people at a playground. What is the population? The population is all the people in the city. What is the sample? The sample is the 150 people at the playground. Now ask yourself, is the sample likely to be biased? Yes, it could be. People already at a playground may be more likely to support a new park than people who don't use parks very often. So even though the survey has real numbers, the sample may still push the results in one direction. That's exactly why samples and populations matter. Here's another important idea. A sample is more useful when it is representative. That means it reflects the population well. A representative sample includes the kinds of people or objects that make up the whole group. If the population is all students in a school, then a representative sample should include different grade levels, different schedules, and different types of students, not just one small group. So when a sample is random, it has a better chance of being representative of the whole population. And when a sample is representative, the conclusions we make are more likely to make sense. That's what we want. We want conclusions we can trust. Let's do a quick check. A company wants to know if customers like a new phone case. They email a survey only to customers who already bought that phone case. Is the sample likely biased or random? It's likely biased. Why? Because the company only asks people who already chose to buy that product. That group may not represent all customers. Now try this one. A librarian wants to know what kinds of books students enjoy the most. She randomly selects the students from each grade level in the school. Biased or random? That is a random sample, and it's much more likely to give useful information about the whole school. Nice work today. Let's keep the momentum going with the next lesson in this series, using random samples to describe populations, where we'll build on what you learned today. For more support, check out my self-paced courses at mathdefined.com. And if you enjoyed this lesson, be sure to like and subscribe. It's free, and your continued support of Math Defined helps us grow. I'll talk to you soon, and until then, keep math awesome.